Alright, so here's the part with that you can use the calculator on. Now I'm going to do it all without a calculator because we should be able to do it all that way. So the first one is if f of 5, or if 5 is a 0, the function f of x, what's the f of 5? Well, if f of 5 is a 0, that means when you substitute in, you get 0, so the f of 5 is 0. And if that means 5 is a solution, so therefore the factor is x minus 5. It's always x minus solution for your factor. Problem 17. Let's see if we can factor this guy. I can see everybody's divisible by 3, and they all have at least 1x. So I'll take a 3x out. Let's zoom in here nice and big. And I can write smaller, and you can see better. So I'm going to take that 3x out, leaving me with an x squared plus 2x minus 24. And then I'm going to try to factor that trinomial. It's got an x and an x, and then to get 24, it's 1 and 24, 2, 12, 3 and 8, or I'm jump right to 4 and 6, positive, negative. And so there's our complete factorization. Problem number 18, x minus 5 is a factor of this polynomial, or the other factors. So what we're going to do is divide this factor out of the polynomial here, and the answer, the quotient to that division, will be the other factor. So I'm going to take that x minus 5, I'm going to use synthetic. We've got all of our terms, so I don't have to put any zeros to hold spots. And remember how this goes. You drop it down, you multiply, and then you add. Then you multiply 1 times 5, or 5 times 1, and then you add 5 times negative 12, and then you add. And so x minus 5 divided into it evenly, the remainder was 0. And then remember, it drops down, it started as an x cubed, and so now this other factor is an x squared. When you get done, you're going to end up with $1,604.71 approximately. 22 here is a half-life formula, or half-life problem. It says half-life of caffeine is 5 hours. And what that means is every 5 hours, the amount of caffeine in your body gets cut in half. That's why it's called half-life. So let's see, you're starting with 120 milligrams. So after 5 hours, you'd be at 60, for example, milligrams of caffeine. And you start at 7 a.m., and we are asked to find out how much is in your body at 10 p.m. Let's see here. 7 a.m. to 7 p.m. is 12 hours. And then 7 p.m. to 10 p.m. is another 3 hours. So this is 15 total hours that we're checking this caffeine level in your body. And so every 5 hours it goes down by a half. So after 5 hours you're down to 60 milligrams. After another 5 hours, so now 10 hours have elapsed, you're down to 30 milligrams, getting cut in half again. Then after another 5 hours, a total of 15, we're down to 15 milligrams. So there's 1 cut in half, 2 cut in half. So it had to be cut in half 3 times, giving us 15 milligrams in our body at 10 p.m. 23, how many complex solutions? Complex means real and imaginary, so that is 3. Find the area of a triangle. We'll give you the formula for whatever you have to calculate. For triangles, it's 1/2 base times height. So they told us the base, x minus 5, so I'm going to put that, I'll put it in pink here. And then you got to take that times the height, and the height we'll do in green, 2x plus 1. So there's what the area of this triangle is. Now, we do want to carry out the multiplication here. Just come up with a nice expression. So I'm just distributing. And I'll collect like terms. So 2x squared minus 9x minus 5. And so that would be a very acceptable answer like that. You could distribute the half, divide everybody by 2, Just depends on what the multiple choice answers are. 25, we've alluded to this. In some classes we've graphed them. It depends on where we've been at and how much time we've had. But here's what you need to know about functions and their inverses. This diagonal line I'm drawing is the line y equals x. It's all the ordered pairs like 0, 0, 1, 1, 2, 2. And inverses are always reflections. So if you have a function f of x and its inverse function, which we put a little -1 above it to indicate inverse, if my function looked like this, for example, so that's f of x, the inverse will always be a mirror image of it. So I gotta make sure I kind of get it right there. We go. Something like that. But you can see they are reflections on that line y equals x, and that's always true for inverse functions, so remember that. 26, just the name of the symbol. This is the fourth root symbol. We've got square roots, cube roots, fourth root, fifth root, sixth root. We've got to add radicals. None of them are like radicals, but this 12 can be simplified. It's 3 times 4, so I can square root the 4. So that's 4 times 2 that will come out. So that 4 comes out as a 2, and 4 times 2 is 8. So here's what I really have to add together. Now again, I can only add, this is 5 of these root 3's, and I got 8 of these root 3's, so that's 13 root 3's added together there, minus 3 root 5. We can't combine these, they are not like radicals. Little distributing property, inside times inside. 4 is on the outside, so it stays on the outside. 18 is a 9 times 2, so it can simplify to 3 root 2 minus 4 root 6. Can't add them or subtract them. They aren't like radicals. See here, 147, we got to simplify it, so we got to see if we can factor it. Not divisible by 2, but 7 plus 4 is 11 plus 1 is 12. 12 is divisible by 3, so when you add the digits, if you get a number divisible by 3, then the original number is divisible by 3. So I'm going to divide a 3 out of that. 3 goes into 14, 4 times, remainder 2, 3 goes into 27, 9 times. And I'm also going to break up my x cubed. And the reason I broke it up as an x squared and an x is because I can square root x squared. So square root of 49 is 7, because it's 7 times 7. The square root of x squared is x, because it's x times x. And I'm left with that 3x on the inside. 30, sorry. Can't break down that, but 24 is a 4 times 6, so that's a 2 root 6. Remember, this is all multiplication up here. This is 3 times root 6 and 2 times root 6, so the root 6 is canceled. 31, what values of x must be excluded? This is a question about that denominator. See how the denominator is factored? That means if either one of these factors ever equals 0, then the denominator would equal 0. So you take each factor, just find out, hey, you can't equal 0 because you would cause us a problem. You would cause division by 0. So x can't be a -4. Same thing with 2x minus 1. We can't have that factor equal 0. And we solve it and we find out x cannot equal a half. A half would make this one right there. 2 times a half is 0, or 2 times a half is 1, and 1 minus 1 is 0. 0 times anything is 0, causing division by 0, which is not allowed in math. That's why we exclude them. And finally, 32 on this page, list all the possible rational roots. First thing you got to remember is you get your p-values, factors of the constant. 1, 2, 3, and 6 all divide evenly into 6. Q, if you recall, are the factors of the lead coefficients, 1 and 2. And then your possible rational solutions are all your p's over q's. So I go 1 over 1, which is 1. Then I go 1 over 2, which is a half. And I keep going with this process, and I go 2 over 1, and 2 over 2, but that's 1 again, so I don't repeat it. 3 over 1, and 3 over 2. And lastly, 6 over 1, and 6 over 2, but 6 over 2 is 3, which is another repeat. All right, page 1 of the calculator portion is done.